Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today we would like to present our integrated design project on the development of interchangeable platform for 3D printer extruders under the supervision of Dr. Sharifah Imhezri binti Sheikh Shaharuddin. Let's begin. Over the years, 3D printing industry has been growing and new advancements are being introduced. New 3D printing machines are also being developed to print different kinds of materials such as plastics, metals, composites, and many more. However, no machine that can conduct both 2D and 3D printing functions into one, and that makes our first problem statement. Based on our observation and research, most 2D and 3D printers have a single extruder, which limits the types of material that can be extruded. And that makes our second problem statement. So, the objectives of this project is to develop a modular platform where various types of 2D or 3D printer extruders can be used interchangeably. The second objective of this project is to simulate the stress induced for the various printer extruders using the FEA SolidWorks. And the last one, the objective is to calculate the overall cost for the new machine with a modular platform for the three types of extruders.
Next, for the conceptual design. The view chart was used for the conceptual design. It is able to provide a quick approach to rank a set of multidimensional design options. So for the modular attaching part, we chose the design concept A because it has more strength, it is easy to attach and detach, and also it has more precise position. For the final extruder, the design concept A has more efficiency and also smooth finishing. For the shrink extruder, the design concept A has better extrusion speed and also better position compared to others. And last but not least, FDM extruder, we chose the design concept A because it has simple design, more efficient and also smooth finishing.
Alright, so this is our full machine design with 4 different types of views. So this one is the isometric view of the full machine. This is the front view, side view, and also top view of the full machine design. The full machine design consists of 15 main components. The first one is base. Base is made by steel bar. Next is this one, main board 1 and 2. The main board is made by plywood. Okay, this one is our printing platform made by A4 size acrylic sheet. So the machine consists of 4 motors, 1, 2, 3 and 4, which will move the part in the desired direction X, Y and Z, right? So at this point 1 and 2, there are rubber which will grip the main board from slip down, holded by the 2 motor left and right. Okay. Alright, for the product architecture, it adopts the modular approach for the overall extruder system, which consists of interchangeable platform board, holder for extruder and also attaching part. As you can see here, the attaching part was designed with a T-slot that will allow the extruder to be interchangeable. This one is the modular interchangeable platform. Okay, so by having this interchangeable platform, 3 types of different extruder systems can be changed easily. Alright, so based on the previous slide, there are 3 different type of extruder system, right? So this one is the detailed specification of the extruders. For the funnel type, The diameter of the holder is only 60 mm. For the FDM extruder, the holder dimension is 58 mm times by 52 mm. For the syringe extruder, the board at the back dimension is 222 mm times by 50 mm. Alright, for the prototypes development, we only focusing on the funnel type extruder system. Okay, as you can see here, this is our prototype for the project. This one is the interchangeable platform board. This is the modular interchangeable platform. This one is the funnel extruder holder. To attach the modular interchangeable platform to the board, we use 4 screws. Alright, so this one is the specification of the fabricated parts. This 1 to 3 parts is fabricated using 3D printers using PLA filament. This one, funnel extruder, is fabricated using aluminum alloy.
I will explain about the finite element analysis. As you all know, finite element analysis (FEA) is the numerical simulations of any given physical phenomenon using the finite element method, which is FEM. Usually, engineers utilize FEA software to reduce the amount of physical prototypes and experiments, as well as optimize components throughout the design phase to build better products faster and at a lower cost. So, this finite element analysis involves on 3 extruders, which are funnel extruder, FDM extruder, and syringe extruder. Materials that are used for our FEA is aluminum alloy 7075 because it has high strength to weight ratio, high resilient, ductile at low temperatures, and corrosion resistant. There a table provides about the properties of the materials. So, we use force in our FEA analysis based on the full machine mass, which is using the formula weight equal to mass times gravity. So we got the mass of 7.8631 kilogram, gravity of 9.81 meter per second square, and we get the weight of 77.137 Newton. This is a simulation of our funnel extruder FEA. Next is the FDM extruder FEA. Next is the syringe extruder FEA. Okay, so the results for the 3 extruders we get is for the max von Mises stress, we use the Newton per meter square. We get in the range of 2.008 10 power of 6 until 2.713 10 power of 6. For the max resultant displacement, we use the millimeter, which is we got the range of 1.506 10 power 4 until 3.306 10 power 4. For the strain, there's no unit, so we got of 2.410 10 power of 5 until 3.306 10 power of 5. Okay, for factor of safety calculations, this is the example of one of the factor of safety that is being calculated, which is for the funnel extruder. So the max von Mises stress for this funnel extruder is 2.609 10 power of 6 of meter per meter square. So we change it into megapascal, we got 2.609. Same goes to yield strength. We change it to megapascal, we got 505 megapascal. So the formula for safety of factor is yield strength divided by maximum von Mises stress. So from there, we got 193.56. So this is the result for all 3 factors of safety, which is funnel extruder is 193.56, syringe extruder is 251.49, and FDM extruder is 186.14. So the factor of safety should be more than 1, and this has shown that all 3 extruder is more than 1. So that's all from me. Thank you.
Next, we will look at the total cost of the machine. It can be divided into two, which are the bought components, where the parts are bought off shelf from the market, the fabricated components, where the parts are fabricated through welding or rapid prototyping process. The table shows the components that are needed to buy, and the total cost of the bought parts is 537 ringgit and 90 cents. Next, cost for the fabricated part, and the total cost for fabricating the parts is 177 ringgit and 30 cents. Then we move on to the labor cost. By factoring the labor cost rate and the direct labor hours, we can get the total labor cost of 200 ringgit. The total machine cost is the sum of both bought and fabricated component costs. Then we add the labor cost to get the total product cost. We factor in the profit margin, which is 40% the total product cost, and then the selling price of the product cost 1,281 ringgit 28 cents. We found that the estimated selling price very reasonable and it's cheaper than our later product. But if we include the cost for the integrated software for the machine, it would push the price much higher. But given that the unique feature of our product, the price is considered a very reasonable and value for money. Next, we move on to the product benchmarking. It's a way to discover what is the best product that are available in the market, and we can use them to compare to our product. However, since our product is focused on the interchangeability, therefore currently no available products that have this feature. So we compare our product to the nearest in terms of function, which is the Ender 3 Pro 3D printer, and the selling price is 1,441 ringgit 93 cents.
Finally, I will conclude our project. Our project, Interchangeable Platform of 3D Printed Extruder, helps in solving the societal problem. Firstly, the interchangeable design reduces time and effort, which leads to more research can be done. The next one is there is a reduction in production time, which in turn will lead to cost reduction. Our project not only will give impact to the society in terms of the quality of life, but also to the environment that they all live in. By using this 3D printer, there will be a reduction of waste due to high degree of accuracy and less usage of material needed. This is related to the Sustainable Development Goal number 12, titled Responsible Consumption and Production, in which one of the targets focus in the management of all waste through prevention, reduction, recycling, and reuse. And lastly, we have concluded that we have achieved the 3 objectives that we have set at the start of this project.